this video, we will continue on the series of Minesweeper in SDL3. If you would like to follow along with this video, you can go to github.com and then sort of called Programming Rainbow /Minesweeper -C SDL3. You can clone this repository, move inside the directory, and open it up with whatever editor you would like. So this is NeoVim, and this is where we left off in the last video. So this is the 5th video. And the last video is the 4th video. So if this is the first one that you're starting off with, you're going to want to take the code from video number 4 directory, and you're going to want to delete this source directory and copy video number 4 and rename it so that you are working with the code that we are in this video. Otherwise, what you'll find in the source directory when you clone it is the final code. I want to show the final project real quick. I'm just going to compile the code from video 10, looks like. And this is what it looks like, and we can change the size. Let's make it a little bit bigger, and I'm just going to click around some places. This is Minesweeper. Basically, if there's a mine here, it'll say that there's, we'll have 1, 1, 1, 1 because this tile is connected to one mine. This one has 2. That means there's a mine here, and one of these other ones is also a mine. But it's going to be this one because there's a 1 here, if you haven't seen this game. I'm going to click on the mine to end the game, just to show you what it looks like. And there's some different theme options and everything. I've kind of talked about this several times before. So this is what the game looks like. This is the number of mines that you have minus the number of mines that you've indicated. So that number will change whenever you indicate more mines, whether you're right or not. And this over here is the time. This will reset the game. And you can click different places. You cannot win or lose on the first turn. And there are different difficulty levels, different size levels. You can also change the size that it's displayed. And there's all kinds of different options. So let's just get into where we left off with the last video. So I'm going to use the makefile again, and I'm just going to, if I just use make without specifying a source directory, it's going to build what's in here. And since I left off with video number 4, it's going to build video number 4. And this is where we left off with. We have the window being properly created. We have the border being drawn. We have the board being drawn. And in this video, we're going to draw the mine indicator right here and the clock. These two are going to be very similar, so I've just thrown them both together. So what we want to do is we want to create a couple files. I'm going to call the mine indicator, just going to call it mines. And the other one I'm going to call clock. So I'm going to have clock and mines. Those are just basically the 2 indicators. And we're just kind of setting up the basic drawing in this video. They're not actually going to be counting or functioning like that, but they're going to have all the image and being displayed correctly and all that. So that's what we're targeting. I'm going to go over here and I'm going to make a couple files. So you can do it in any editor you want. It's really unimportant to this. So whatever you're comfortable using, whatever you need to do to make new files. So this is going to be mines.c and mines.h. And also I'm going to do a clock.c, clock.h. So that's mines.h and then clock.c and a clock.h. So in mines, we're going to put our guards on. So we'll do our if and def, mines.h, and we'll do our end if down here. And right away, we're going to include main. Okay, so now we can set up what this is going to be. It's going to be a struct with some functions, as I do with all of them. So this one's going to be called mines. And this is going to look very much like the board and the border kind of a struct, where we need a render. We're going to have a pointer to an image, and then we're going to have an array of recs so that we can index into it. But on this one, on both of mines and clock, we're actually going to have 2 sets of images. Let me show you what's going on here. So these are all the images that are used in this project. Here is the icon PNG. This is the faces. This is the digits themselves. And this is the background of the digits. And then we have the border and the board. So we've already seen the border and the board. But what we need is both of these. We need to draw the background and also the digits. And we have two versions. We have a color version and a black and white version. We're only going to be working with the color version in this video, but in future videos when we can change the theme, we'll already have that in place. Okay, so I'm just going to show you what these look like a little bit bigger. This is the background. So it just has kind of a border accent color. And these are the actual digits. So we have all of the digits here available. And this is if we were doing a color theme or one of the monochrome themes. So I'm just showing you we're going to be loading both of these images in. So we do need a pointer to the renderer. And we're just going to call it render. And then we need two different pointers to images. Okay, so I'm going to call one back image and the other one digit image. And we've already seen how we're doing the image with the texture and all that. So I'm not really covering that because we've done it in the last several videos. If you don't know what I'm doing, though, please refer back to, I think, video 3, 4. And this one is called digit image. So those hold the actual textures, but the way we're deciding what part of that texture to display is with source rectangles. So I'm going to have a back source rex array and a digit source rex. Again, it's just like the board and the border, but we have two images that we're dealing with. So these will be frex. And this is going to be an array of them. So normally the frect is just the rectangle itself, but because it's an array, it's a pointer to an frect. So this will be called digit source rex. Or sorry, we'll do back first. Back. I'll just do src rex. And this one will be digit, same thing, src rex. And we will also need a width of a digit and a height of a digit. And these will be in floats because these are going to be used in the frect, and the frect is a rectangle of floats. So we will be using a float here. This is very much like in the board, I think, we use the size in the border as well. We had a size of one of the pieces and the height. So this one will just have the width and the height of the digit. Digit. Oh. Sorry, I'm going to put the semicolon here before I forget. So the functions we want is the new, the free, and the draw. So we've kind of seen these functions before. New is a bool, and free and draw are both void functions. And this one will be pointer to mines. And we also need the SDL render passed in. And the void mines free. Again, we're doing the pointer to pointer. And that's all we need on this one. And then on the draw one, it's going to be const, because we don't need anything to change while we're drawing it. Const, and then we'll do struct mines. And since I'm not doing a pointer to pointer, I'm just going to use the star m. That's just my own kind of scheme. I always know when I see that exactly what's happening. Okay, so I'm just going to grab these function definitions here. Function signatures, sorry. I'm going to include that header file that we just made. Not main.h, sorry. Mines. All right, so this is going to look very much, at least in the beginning, the way that the other ones looked, the way that we calloc it and everything else. So we're going to dereference because Mines is a pointer to a pointer. This is so that we can change the pointer inside of the function. So we've sent in a pointer to a pointer, but we also need to dereference it when we want to use it. So we're going to calloc, and this is just one size of one of them. Size of struct Mines. Now let's make sure that that is Mines is not a null pointer, because if it's a null pointer, that means that function has failed. And if it has failed, we'll use the file descriptor formatted print. I'm not sure exactly how you say it. It's printf, but you're sending, you can choose the file that you're sending it to. So fprintf. And the file I wanted to send it to is standard error. So it doesn't go to standard output. We'll say error in calloc of new clock. That's probably good enough, yeah. And we'll return false from here. So if this did work out, I don't want to keep dereferencing Mines. So I'm going to quickly make an M that I can use. So M is a pointer to a Mines struct. I'm just going to dereference that Mines one time. So this is still a pointer, but this is a double pointer. So dereferencing it one time gives me the pointer. I assigned it to this one. That's just so I can use it a little bit easier. So the first thing I want to do is pass this render. So M. So I don't have to do this. Well, I'll show you. I'll do it this way, and I'll show you the other way. So I have this. This is setting the render that I just passed in here to the render pointer that is held in this struct, right? Now, if I didn't want to use M that I've just created here, if I wanted to use this M here that I've passed in, I would need to do this. You know, and that's more to write and a little bit harder to read. So that's why I just do it like this. Okay, I'm just going to do the return true. It doesn't complain at me. So now what we want to do is I want to set up the rectangle first and the width and the height of the digit first. So the rectangle, we're going to be drawing two different things. Over here, we have this digits that we're going to be drawing. We're going to be drawing 3 digits, but we also have the back that we're going to draw. So since the back is always going to be in the same spot, it's not going to move. I'm going to set a rectangle up for that. And also I can use that to position the digits as well. But the digits, there'll be 3 different digits in different offsets. So I'm going to hold a rect for this one because this doesn't change. And then in the drawing function, the draw function, I'm going to create a rect inside that function that has the digits. So I don't need to, because it's a const, remember, I'm not trying to change anything. So it'll kind of make sense, but basically I need to draw 2 different things. The background doesn't actually change, it doesn't move. I just need to draw it one time. So I'm going to hold that rectangle. Let me look at the header file real quick. So this is not right. We are missing something here. We need the rect just for the background that I just said we were going to draw. So we do need an SDL F rect here. And this one is not an array or anything. This is just actually a rectangle. So I'm going to call it back dest rect. So this is one rect. This is just for the background. The one for the actual digits, I'll create them inside of the function, but it'll be based on this. Okay, so you'll need to add this one rectangle here. Since this is kind of already going to be set, I'm just going to set it now. This rectangle. So the back destination rect.x is going to be the digit back left, and I haven't set this up yet. So before we fill this in, we need to go to main H. Unfortunately, a lot of these are just numbers I figured out. So they're just kind of magic numbers, but they are going to be scaled. So the digit back, the width of it is the actual width of one of them. So if we look up here, so this is 82 right here. That means the width, this is two backs. This is the color one and the black and white version. So if the width is 82, one of these is going to be 41. So the width of my digit back is 41. The height of this is 25. So the height is going to be 25. And the top, how it's offset, I've just figured it out, but it's 15 and 15. Where we're going to be drawing this from basically the top of the window, it's going to be 15 down and 15 in from the left. And from the right, whatever I decide is the right side that I'm drawing, I'm going to be offsetting it in 3. So it'll kind of make sense when we draw it, but I'm just kind of telling you where I got these from. So this is digit back width, and this one's going to be that 41 because that's going to be the width of one of those images. So this will be back height, and this will be 25, I believe. And then we have this is where it's going to be placed in the top left-hand corner, and it's 15 and 15 for both the top and the left. I'm going to call this top. And this one's also going to be 15. Later on, when we do the right side, for the clock, it's going to be 3. That's an offset. That's just wherever the right side of it is, it's going to be 3 more pixels inward. It keeps adding, yeah. It just randomly adds numbers for me. So I also need the digit themselves. So this is the digit back, the background piece behind the clock and the mines. But each one of the digits is much smaller than that. They're 13 wide and 23 tall. So they're a pixel on the top and bottom smaller, shrunken in. And if you were to add up all the digits together, there is a pixel to the left and to the right as well. So there is a kind of a 1 pixel basically offset in when you're drawing it, but that's also scaled by the size of it. And we're scaling by 2 right now, so that would be 2 pixels. So this will be digit width, and it's 13. So if we go back over here, right here, if we were to take the width of this and divide it by how many digits there are, that looks like there's 12 digits here. So this is 156, and if we were to divide that by 12, we would get something like 13. And the height of it is 46. So it's 13 by 46. Height 46. Okay, so that's all our constants that we need, and this will work for both the clock and the digit, or the mines and the clock. So back up here. So now we have the digit back left is where the X is going to be. But we need to scale this. We're just scaling it by magic number 2. Later on, we will change this. We will make this dynamic later on, but for now, we're just scaling it by 2. So that is and the Y is going to be the same. It's going to be digit back top. Now we have the width. And this is just digit back width. times 2. Okay, so there's our width and our height as well. And now on the other one, I just need the width and the height of an actual digit, because I'm not going to set up another rectangle here because I need to move the rectangle into 3 different spots. So I'm going to do that inside of the function for the digits, because if I set it here, I can't mutate it inside the function because it's const. So I just need really the width and the height. So we'll go digit width equals digit width. And the reason why I'm not just using this directly is because, again, this 2 will be changed later. So these will be recalculated, and this is being held inside of its local variable so that it always knows what its own size is. We'll see it later on when we set up the scaling and stuff on this. So this one's going to be digit height. Okay, so that's kind of setting up a rectangle and our width and a height. We're going to use that load media sheet function that we've already used before. We've seen this before in like the board in the game right here. So I'm just going to grab this since it looks the exact same. Okay, but for one, we're not using B, we're using M, so we'll change that real quick. And we don't have an image. So our image is not called image here because we have 2 of them. Our image is called back image, I believe. That should be right, back image. And then it's going to be back source rex. And this isn't M either. It is. Oh, it is M. And we need to include this. This is load media. Okay, so this is the name of where we're storing the image. This is the rex, right? But we want the back image. So let's see what that's called real quick. It is called digit back. That's the image we're looking for. So digit back, and right here, this is going to be digit back width and digit back height. This is how it breaks it up. You know, it needs to know the width and height of each image so it can break up that into like a sprite sheet kind of deal. It breaks it up into the recs that you need. So it needs to know what's the width and the height of a single one of those images. Okay, so we have the render. This is the target pointer that we're going to keep it in. This is the actual PNG image we're loading. This is the width of one of the sections of the image, and this is the height of one section. And this will be where those rectangles that get generated are stored. Okay, so it's going to fill up that one, but we do have 2 images. We have the digits as well. So I'm going to yank this again. And this one is called digit image. Digit image. And let's see what the PNG is called. So the PNG on this one is just called digits. And now we're going to need the digit width and the digit height. I think that digit source rex is where they're being stored. So this is for the back. So we have back image, digit back is the PNG, digit back width, digit back height, and those rectangles generated are stored in back source rex. For our digit, we have digit image, is the pointer that we're storing this at. The PNG is digits. We have digit width, digit height. Those are defined in main.h. And we are storing the array of recs and digit source recs. This is where we're going to be able to index the different ones for different themes and for the digits themselves for the 0 to 9, that we need to draw. Okay, so this will be the entire setup here for the Mines new. So Mines free. The first thing we're going to do is make sure this is a populated pointer. If it's not, the if will fall through and we'll never do anything. That's fine, because if it's a null pointer, we don't want to try to process it any further. Struct mines. I'm just kind of doing the same, dereferencing it so I can get it an M. M is a pointer to mines, so I don't have to deal with that double pointer. What we want to do is we've allocated space for the recs, and we've allocated space for the images for both the back and the digits. So we need to free both of those. So we'll make sure that each one of these pointers is not a null pointer. So the last one that we added was the digits, so we'll do it in reverse order. It doesn't really matter, but I just like to always do things the same way, so it kind of stops me from making unnecessary errors. So we can get rid of the recs first, so it'll be digit rec. So if this is a populated pointer, say free rec source, and then we will set that pointer to null pointer. Okay, and this also has these were the rectangles, but there was also a texture associated with this as well. So the texture was the digit image. So we're checking the pointer. If that is not a null pointer, we want to do the SDL destroy texture. And the same, we want to set that to null. Okay, so we want to do the same thing again for the back. So I'm going to yank these two. So this is back source recs. And this will be back image. We're also going to set the render to null. We don't free it or destroy it because this is just a copy of the pointer. The actual one is in game. But just again, doing the safest practice, I just want to set it to null because I'm no longer going to be using it, and it could be freed in game. So let's free M, which is this struct that we're inside. We'll set M to null, which is just the local. The M is just the local pointer. Now, it did free it, not the local one. It actually frees the real one, but setting M to null is just the local one. So now we can set mines, the dereference mines to null, and this is the real pointer right here. And let's give ourselves a little message so that we know that this function did get run. Mines clean. Okay. So this is everything that we need here, except the drawing. The drawing, we're drawing two different things. I'll show it after we have the first one so that we can see how it's being drawn here. So I just want to draw the back, not the digits themselves, but this the digit back. So we already have the rectangle and everything set up for that. So I'm going to say render texture, and we need the render. And we need the image. This will be back image. And then we need a source rectangle. We need a pointer. Sorry, we need the address of the source rectangle. So this will be back source rex. And this is an array. So we need to choose one of them. I'm going to choose 0, which is the first one. And this will be changed later as well. I just want to draw something in this video later. This will be dynamically set with whatever theme that you're using. And the digits themselves will have a theme part and which digit you want to display. But so this one is just a background. So this 0 will be set with a variable at a later date. But the 0 just means the first one. So what will be drawn here is this one right here will be 0, and this will be 1 because it's array and there's 2 of them. And we need the destination rectangle. So that's the source rectangle. So we're finding out what part of this image to draw. And this is going to give us basically the left half of the image. And the destination is where on the screen that this is going to be drawn. And we've already set that up in the top up here. This is it right here being set up. So I'm just going to use that. So it's back dest rect. Yeah. And it's the address of it. Okay, so that's just going to let us draw something. So let's connect this up and see something before we draw digits on top of it. So in game H, I need to pull in this mines. So mines.h, and I'm going to add it here. And I think that's everything in here. Yeah, so in game C, we just need to do it this way right here. I'm just going to yank this. It's going to be just like that. But we don't need rows and columns. We just need the render, and it's called mines new. Okay. And this right here is mines. Okay, so that's how we're initializing and getting it, set up in memory. But the way we get rid of it is the same as these, except I'm going to put it on the top because this is the last one we added in. So this will be G mines, making sure that pointer is correct. And it's mines free. We need to send in the address to it because we're changing the pointer inside of this. Okay, so that brings it online. This brings it offline. And now we need to actually draw it. So down here in the game draw, I'm going to tell mines to draw itself. Okay, so we should be able to at least have basically a black rectangle on the left side in its correct position, hopefully. If everything has been done correctly up to this point, I'm doing a make clean. I don't really need to do the clean, but it's fine. It'll work. Okay, it looks like I've messed something up here. Well, it says it's in clock 2. I don't think we've put anything in here yet. Hold on. It's probably upset because there's nothing there yet. Because we're messing with mines. I'm just going to delete these for now. And we don't need to clean. I'm just going to tell it to do a release build. There we go. It was probably just didn't like the fact that we had these empty files. So that's the back. That's the digit back right there being drawn. And then we're going to draw images on top of it. Okay. So down here in back in draw. So I'm going to create the rectangle right here in place. Because again, I could create a rectangle and then mutate it, but we don't need to mutate anything or const. So I could just create the rectangle here. It's not really a big deal. It's just a little rectangle. So it's SDL F-rect. And we'll call this digit rect. That'll work. And I'm just going to set the x at 0. I'm actually going to set it right away inside of a for loop. But for right now, I'm just going to set it at 0 because I don't need to set it twice to do the same thing. So what I want to do is I want this digit needs to be offset by one pixel, but also scaled. And right now we're doing everything by 2. So that 1 pixel times 2 will be 2. So I'm just going to hard code it 2 for right now. But later on, again, when we deal with scaling, that'll be changed. But basically, I need this one more to the right and one more down because we need that border. There's a 1 pixel border all the way around this that's being drawn. So my digit is, 1 pixel in to the right and 1 pixel down. So I'm going to take the destination, rect, and I'm going to add 2 to it. That's going to be that 1 pixel, but we're scaled. We're in a double scale right now. So I'm just going to add 2 to it. And that gives me the x. That gives me the y position. Sorry, this should be dot y. We're going to do the same thing for the x in a different part of the code. And now our width and our height is just our digit width and digit height. So that should work there. So we need to draw these 3 digits. So I set up only the y position, but not the x position, and the width and the height of this rect. So in the for loop, we need to draw 3 different digits, and I'm going to calculate the x inside of this because we have 3 different x positions to draw this digit at. So we'll say for int I equals 0. And I'll say I is less than 3. I++, there we go. So now we're going to calculate the digit rect x. So this is going to be basically, we're going to use the x position of the back, but then we're going to multiply it by the width. Sorry, not multiply. We're going to add to it a multiple of the width. So let's start with the first starting position. The first starting position is going to be equal to the back dest rect for x plus 2 because of the scaling. So that's going to give us our very first one. What we want it to go to all 3 inside of this loop. That's going to go 0, 1, and 2. So what we can do is we can add to it the digit width times the I. And I think it's going to complain it's not a float. We'll find out here in a second. So on the very first iteration of this, when it's 0, this will be 0 times width, which will just be nothing, and we'll start at our normal x position. On the second times through, this will be a 1, and what will happen is we have our original x position, but now we're shifted over the width of 1 digit. And on the second time through this, or the third time through this loop, this I will be a 2, and so we have 2 times the width. So it'll be the original starting position, but shifted over 2 widths will give us our third spot. Hopefully that makes sense. If this was our 3 spots right here, like right here and right here, 0 is here, our x position plus 0. If I take our x position plus the width, we get over here. And on the third one, if I take the x position again plus the width of 2, we get over here. So the item is drawn here. If that makes sense. I hope that makes sense. And we might have to cast this to a float. I'm going to try it without doing that, but I believe that we will have to. Okay, so now that we have this digit rect, well, 3 different spots that it'll be in, we can draw it. So we got render texture. And we need the render. And then we need the image that we're going to be drawing. So we got digit image. And we need our source rectangle. And I'm just going to use 0, which is going to be a 0 for right now. I'll show it to you again. So 0 will be this image. So if I put 1, it'll be here all the way up to 9. If I do 11, it'll be the minus. And if I do, sorry, this will be 10, this will be 11. This is the 12th image, but it's indexed as 11 because this is 0 image. So the 12th image will be kind of a blank one. But with the color one, we have this kind of dark color background. With the black and white one, we have actually nothing. So we can see it, but I'm just going to put 0 in right now so we can just see something. So the address of our digit source rex and the index of it will be 0. And then we have the calculated, the digit rect that we just calculated the x for. So we just kind of send in the address of that. And that should be all we need. This isn't digit width, this is digit rect. I was thinking my head width. Now let's see if we get away with this I without casting it. And we didn't. So we're going to cast this I to a float. That's because my compiler is a little bit strict. I think our height is incorrect. At least our height of what we're drawing. Where is that? Oh, okay. Hold on. Did I set it incorrect? Digit height times 2. Let's check in main. Digit height is at 46. What's the back height? The back height's at 25. This is just wrong. I know what happened. I probably looked at it and it's half of this. It's 23, probably. Let's look at the image. Yeah, so it's 46 for 2 high. You know what I mean? For 2 of them. So half of this is 23. It's supposed to be 23. And there we go. So now we can change this. So it doesn't have to be 0. We could put something else. I can change it to the one that was the behind it. Or is it mine? So the 11th spot was that kind of one that is not a number at all. There we go. We have the little bit darker red. And you get the idea. Later on, again, this will be decided by other variables calculated here, that what gets drawn in each position. But for this video, we just want to set this up in place, get it up and running. It will be deciding what's actually put in, what gets put in here for each one of the iterations through in another video. So I'm just going to set this back to 0 for now. So what I want to do is basically the clock is very similar to this. So I'm just going to copy these 2 files. I'm going to go into game and set it up first. So game is going to have, it might complain, whatever. I'm just going to let it complain for now. This will be clock.h, and this will be struct clock. It's going to complain because it doesn't exist yet. But it's fine. It will in a second. In game C, we're going to do this same one. Well, let me just, I guess I'm getting ahead of myself because I wanted it in place, but we don't need to. I'm just going to copy these. So this mines.h, I'm going to copy it, paste it, and call it clock. Okay. And here is going to be clock. So I'm going to kind of do a search and replace on this. And it's going to mess some of the capitals up, but it's fine. So this needs to be capital here for my naming scheme. And that means these as well need to be capitalized, all the structs. This is going to be a C here. And back digit's the same. Yep, that's the same. That's the same. Oh, that's the same. So I think this is good, hopefully. So I'm going to copy now the C file. Okay, I'm going to do this one in sections because it's going to be a little bit messier. Okay, so I'm just going to take the first section here. I want to see if I can deal with the dereference of the M right there. So let's see. That changes all the M's to S's. That's fine. Now we can say mines, clock. And now this is going to mess up capitalization and stuff like that. Here, clock. This here is clock. Oh, I changed the M's to S's and they were supposed to be C's. Hold on. So, all right. Hopefully that's correct. More correct. Not correct. Clock. Right here, this needs to be capitalized. Okay, now we're looking better. So most of these are probably the M's need to be set to C. Clock. And this needs to be clock. Oh, this is all. And down here. Okay, that looks a bit okay. Could be still issues in there, but not too bad. No complaints here. Okay. So now we can go back into game and set it up correctly. So it's not, we do need to go and edit clock because the X position's different. So I'm going to yank this, but I do know that this is going to have another thing that I pass into it right here. For clock, it's going to be, we're going to be passing in columns as well. It's going to complain because I haven't set it up yet. I didn't add this yet, but we do need this because the clock is going to be on the right hand side. This is going to be the same here. And the drawing of the clock is going to be the same. Okay, so it's going to complain about this up here. In clock H, let's fix that. And I want to know if that is an unsigned or an int or what. It's unsigned. Okay, so I'm just gonna follow that. Column. So that should fix the problem in game. Yeah. So we have these columns that we're passing in. Now in clock, we need to change that as well. So I'm going to hold the columns locally because we will, when we rechange the scaling or change the size, we will need, the columns will be reset on us. So this will be unsigned columns. Columns equals column. So we're past the columns in. Now we have to calculate where is the X position of the back destination rec, this one right here. But this can't be in the same position. This is going to be on the right-hand side. We need it to be on the left-hand side. But we don't know how big the screen is. We don't know what the scaling is, all of that stuff. So this has to be calculated. So it's going to be, I'm going to calculate it by the piece size. I'm going to find out where the piece is, but where the right side of the last piece is. So I'm going to add one more piece to it. So this is piece size times, and I'm just casting one of these to a float. So what we need here is we need the columns plus 1. So wherever the columns are plus 1, because we don't want where the last column is on its X. We want the right side of the last column. So we're just going to add one more column to it. But it's going to complain about this. It wants this to be cast to a float. So that's set up there now. So this multiplication is going to happen first, and after that, we're going to be subtracting the border left. And then subtracting the digit back width. And then we're going to subtract the digit back right, which is basically another 3 pixels. I know it's a bit weird, but that's how we're doing it. And we need to scale this, so we're going to times it by 2 here. So that should be the whole thing. that gives us that. The rest is actually still calculated the same. Yeah. So let's just see if this compiles now. We don't need this up here. So let's see what happens. And got a mistake here. Mines free, no previous prototype. It's spelled differently. Oh, this is in clock. Where was that? Yeah, the function name itself is wrong right here. This is a mines, it should be clock. And this also needs to be changed. Okay, so this is one side and this is the other. Now, if we scale this, it should scale correctly, you know, but we haven't set up scaling yet. But because of the way we're calculating this, it's going to be, assuming everything else is correctly set up, the ×2 scaling that we're doing and all that, it's when we use that same calculation, we'll get this in the right spot. It'll always be on the right hand side and offset as much as it needs to be. So that's kind of a whole bunch of kind of boilerplate stuff. I mean, we are doing the same thing twice here, but there will be other code inside here that deals with what's actually being displayed. This just kind of sets it up for us. And do make sure, I'm just going to do search in here, that there's nothing in here called mines. Yeah, there's nothing in here called mines. Okay, and what about here? Yeah, there's nothing in here called mines. Okay. Because it's a bit weird when I copy these files over, you know, you have to change it. Everything that is capitalized, it still needs to be capitalized. So you have to fix these clocks struct names because they need to be capitalized. In my search and replace and NeoVim here, it doesn't do that. And I think most programs don't do that. They don't do search and replace that is like case sensitive always. If you just did what I did, make sure that all the struct are struct with a capital C. And you might have some where I do the C, like right here. This could be an M right here, you know. So you do have to kind of look through. That's why I did it in sections. But anyway, let's look at what we've done here. So we have this mines. Whoops. So in main.h, we've added a couple new things here. These right here, setting where the mines back is, the width, the height, the offset of the top, the left, and the right. We also have a width and a height for the digits themselves. And mines right here. This is very simple. We have the renderer. We also have 2 pointers to textures, the back texture and the digit texture. That means we have 2 set of arrays for frex, a back source rex and a digit source rex. We also have just the rec to display the back because it's just in one spot all the time. And we have a width and a height for our digit, so we can use it for calculation. We have our functions new, free, and draw. We've seen this many times before. And we're just basically going through and we are instancing it, you know, allocating the memory on the heap. We're passing the render to itself. We're setting up the destination rectangle for the back and what the width and the height are going to be set to for each digit. We're using our load media sheet from the load media module there. And we're using this to load the background image and set up its rex, and to load the digit image and set up its rex. Our mines free, we are freeing we're checking to see if the pointer is valid first on all of these. And then we're freeing the array that was allocated on the heap for the rex. And then we're freeing the image and setting them both to null. And we're doing the same thing with the back. We're setting the render to null. Then we're freeing this actual allocated for this struct on the heap. And we're setting it to null, even though that's the local one. This is the important one, the asterisk mines. This is the dereference of the real pointer that needs to be freed. This one right here, I'm not sure if I changed it to clock in the other one. I have to check it. So we are drawing the background, and then we are creating a rect for the destination of the digit, and that is going to be changed. The x of that is going to be changed in each iteration because we need three different digits to be drawn, and so we're calculating it each time with an offset of the width of one of the digits multiplied by the index here, and then we're just drawing that out as well, and these will be changed later on to do other things. Our clock one is almost the exact same, except we're just changing where our x is, our x position. We're trying to calculate the right side of it, which is right here. We also have the columns stored that we'll be using. Cleaning up is all the same, and drawing is all the same. So pretty much everything's the same here except the addition of the columns and the calculation of the destination for both recs, basically, for the back rect and for the digits rect, because it uses that. Okay, so I hopefully explained all that. It's kind of like boilerplate stuff, setting things up, but at least now we have being drawn the mines indicator and the clock indicator. And there's nothing new. That's why I didn't show any functions or anything, because there's nothing new going on with any of that in this video. Okay, so I hope you enjoyed that. If you have any questions, just ask them in the comments below. That's going to be it for this one. The next one will be drawing the center face, and then we'll actually start making the board work. That'll be fun to actually get the board up and running, so it's actually, you know, doing something for the game. I'll decide which one I'm going to do next, actually. Thanks for watching. I hope that was entertaining or educational. And if you have any questions, let me know. And I'll see you in the next one. Bye.